Hi there, Mr. Holcomb here with another episode of The Math Behind the Modules. This is lesson 21. If then moves with integer number cards. Okay, so this classwork exploratory challenge integer game revisited is an example that we did in class. We actually did them as a group. So what they want us to do in this is pass out cards between -2 and 2, inclusive. So rather than doing that, I'm going, and I can't show you that on screen, I will use my calculator, and I'm going to use an option on my calculator in the probability file that's called random integer. So I'm going to choose that, and I'm going to tell it to choose values between -2 and +2. So this is going to randomly give me -2, -1, 0, 1, or 2. So when I hit enter, that'll be my first draw. Okay, and I drew a 0. So I'm going to put that 0 right here. So that's my first draw. Now I'm going to go get my calculator again, and I'm going to hit enter. That'll be my draw 2. And it was a number 2. So I put that there. And then one more time, hit enter, and I got -1. So it says my score. Well, 0 plus 2 is 2, and 2 minus 1 is 1. So my total score is a 1. All right. So there is my score from drawing 3 cards. So I have a total. Now what we're going to do is after that I had them do certain things after. So event 1 was to give the students 2 or more integer cards, one for each student, containing the same positive value, and ask them to record the change as a result. So we're going to do that here. So what we are going to do is say, let's put down here, we have a 1, and I'm going to draw a card for this person. And if we were doing this in class, say I pass this card and it's a 0. So I'm going to give this person a 0. So what they did was they would take 1 plus 0, and my new score is still 1. Over here, let's just say this person had a different group of cards, and let's let the calculator choose those 3, and I'll do that in a different color. So if I hit enter, -2, 2, and -1. So -2, 2, and -1. So these two are partners, let's just say. So the first person got this total, and this person, so I would have to have a star here. Well, that's a bad star, but I like it. Okay, so -2 plus 2 is 0. -1 is a -1. So this person here had a 1, and this person here had a -1. This person is going to add that same 0 in that I gave, and their new result is -1. Okay. Okay, let me stop right there because that's not what I want to do. Let's just come up with a way to identify a same totals, what I was supposed to do here. So I didn't allow them, I had them group together people who had the same value. So how about, let's make this 1. So just bear with me a moment. I'm trying to just set this up properly. And this a 1. So my new value is not -1. It is 1 plus 1, which is 2, minus 1, which is also 1. So now I'm going to add 0 to this 1 and get 1. So let me recap what I was doing here. Person 1 had a 0, a 2, and a -1 with a total of 1. This is person 2. They had a 1, and a -1, which adds up to 1. So what I had the students do in class is pair up with someone who has the same sum. So these two are now sitting together, and they're now adding the value that I get in my calculator draw to what they have. So now I have this conclusion. So first we're going to start with original. Okay, so the original card for person 1 was 0, 2, and -1. The original score was 1. And over here it was 1, 1. Don't want to write them that close, looks like 11. 1, 1, -1, and their original score was 1 as well. Okay, so then event 1, add 0. So event 1, both partners received the 0 card. So their new score is still 1. Okay, now let's move on. So their new score, let's put their scores here, carry it over. So now they both have a total of 1 with that 0. And now what I want to do is repeat the process with one minor change. This time both students receive one integer card containing the same negative value. All right, so I'm going to choose a negative value, the first one that comes up, and it's -1. So the number is a -1. So I'm going to combine my original score with this -1. Well, if I add -1 to 1 on this one, I get 0. If I add -1 to 1 over here, I get 0. So my conclusion is okay, so event 1, both partners received the card -1. Now the new score conclusion is, if the sums are equal, then the same negative or positive number added to the sums will remain equal. Okay? All right, so moving on. So now we still have a total, now we have a total of 0. So I'm going to put a 0 here. And my other person is over here as well. So they only gave me 1 star here for some reason, but we'll continue. That's okay. And the next thing we want to do is pick either the same pair of students or another pair who have original sums that are equal and have at least one identical card. If possible, pick 2 groups to go to the board, and so on and so forth. So exercise 2, one group will have an identical positive card, the other will have an identical negative card. Well, we just did negative, so let's do a positive in this video. So I'm going to hit enter until I get a positive number. And there it is, 2. So I'm going to add 2 to this one. Okay. And I'm going to add 2 to this one. So 0 plus 2 is obviously 2, and 0 plus 2 is obviously 2. And what is my expression? Okay, well, student 1 would be, now let me go back, 0 plus 2 plus -1, 0 plus 2 plus -1, okay, so this was my original 3, and my first event was, I drew a 0. So I'm going to write that here. I'm going to write plus 0. Okay. And then I'm going to subtract 1. And then I finally added 2. So I had 0, I added 2, I add 1, I had an original 1. Added 0, still 1. Subtracted 1, I'm down to 0. Add 2, I'm now up to 2. So, and then if I did the same for the other partner, their numbers were 1, 1, and -1. Okay, so when I go back and do this, then it's going to be 1 plus 1 plus -1, which equals 1, just like this 2 plus -1 did. Now I'm going to add 0, add a -1, and we just added 2. Okay, so the conclusion is, if the originals are equal, you can subtract the same number, or in this case, add the same number. You can add the same number, either positive or negative, and their sum will remain the same. Okay, so let's recap that. So what they're saying is this adds up to 1. This adds up to 1. I added 0 to both of these. Their scores were both still 1. I added -1 to both of these. Now their scores were both 0. And then I finally added 2 to both of these. And we got 2 and 2. So the originals were equal. I added the same number, positive, negative, and 0, and their sums remained the same. And that is the conclusion here. Okay, so event 4. Okay, so this time what we're going to do is we're going to divide this time. So what was my score finally? It ended up being, we're at what? 2. 2 is our score right now. So I have this person here that's got a total of 2 and a person over here that has a total of 2. We are now going to divide by a number, and I'm going to choose random integers between -10 and 10 this time. So if I go to my math, probability, random integer, and ask it to pick values between -10 divided by 10, or not divided by, comma, 10, then I got -6. Okay, so we're going to divide both of these by -6. And obviously if we do that, we get -1/3, and over here we get -1/3. Okay, so the expression now is, let me go back and get it. It is going to be, okay, so I did this off screen just to speed up things. So here's what we have. We have our original 3. We have our 3 operations here. But now we divided it by -6. So if I divide this whole thing by -6, and I divide this whole thing by -6, our conclusion is if, let me just bring that in. Okay, so if the originals are equal, you can divide by the same number, either positive or negative, and their quotients will remain the same. Because in this situation, we got a -1/3 and a -1/3 when dividing by 6. Okay? All right, so moving on to the exercises. The table below shows 2 hands from the integer game and a series of changes that occurred to each hand. Part of the table is completed for you. Complete the remaining part of the table, then summarize your results. So here's our original hand. So we're really just doing what we did with the calculator, and they've done it for us here. We're just going to go through the motions. So the original value of the left, the hand number 1 on the left here is 1 plus a -4 is -3 plus 2 results in -1. So now I have 1 plus -4 plus 2. We're told to add 4 to this, so that's plus 4. So obviously if this was -1 and we add 4, we're going to end up with a 3. Subtract 1 from that 3 and we're going to get 2. Add 5 and -6 and I get -1. So as you can see, our results were equal at the beginning. So I'm going to take this 0 plus 5 plus a -6, and I'm going to do this operation here. I'm going to add 4, and that will result in 3. I'm also going to write 0 plus 5 plus -6 plus 4, and I'm going to subtract 1. So it's going to be -1. -1. So 3 minus 1 is 2. So we continue like this. Now I'm going to write 1 plus -4 plus 2 plus 4 minus 1. And here's where you have to be really careful. In class, here's what a lot of students did. Just put a ×3 here. But if you remember, I'll put it down here. PEMDAS, these are expressions. Please excuse my dear Aunt Sally, whatever you want to call them. Multiplication comes before addition and subtraction. So in this problem, I would just say that this is -3, and I would not get. Now, everybody knows that if I multiply 2 by 3, I should get 6, yes? But think about this. If I do this piece first, now this is minus 3. So all the way up to the 4 was a 3, minus 3 would give me 0. So if I don't do my order of operations correctly, I will get the wrong answer. And in order for this to be correct, I need parentheses here. So PEMDAS says to do the parentheses first, combine all of these to get this 2, and then multiply that by 3 to get 6. Okay, and let me change the color of that 3 to show that was our operation this time. Put that back. Let's use black here. Multiplying by 3. All right, so I'm going to do the same over here. So I need parentheses, 0 plus 5 plus negative 6 plus 4 minus 1, close the parentheses, times 3, and that is also 6. And one more time, now they want us to divide by 2. Now we could put parentheses around all of this and hit a division symbol outside, but I would prefer to do it this way. 1 plus negative 4 plus 2 plus 4 minus 1 all times 3. What I'm going to do now is I'm going to divide by 2 and do it as a fraction here. So do your numerator first, because that is your parentheses, or some call it GEMDAS. That's your group up here, grouping. So if I group these, I get 6. 6 divided by 2 is 3. And again on this side, if I have 0 plus 5 plus negative 6 plus 4 minus 1 times 3, and then I finally divide all of that by 2. That adds up to 6, or this adds up to 2 times 3 is 6. Divide that 6 by 2, and we're back to 3. Okay, so there we go. So we're going to summarize the results now. Let me move this out of the way, and I'll bring the summary down. So the summary is, since the sums of each original hand are the same cards can be added, subtracted, multiplied, and divided, and the sums will remain equal to each other, and the quotients and the products, if you will. Okay, so there you have it. So now it asks us to complete this table below. So they gave us our original expression and results, and they left some blanks here. So, okay, 3 plus a negative 5 is negative 2. If I want to come up with the same outcome, and I want 2 different values, how about I have 2 plus negative 4? 2 plus negative 4 is also negative 2. All right. So now that I've done that, we're going to take the original expressions. And I'm just going to do this first just so we see what's going on. And 2 plus negative 4. And write a conclusion about an if-then statement. Okay, so now it says multiply each expression by negative 3. So if I'm going to multiply the expression, I want to set up another set of parentheses and times a negative 3 here, and times a negative 3 here. So if this is 2, negative 2 times negative 3 equals a positive 6. 2 minus 4 is negative 2. Negative times a negative is positive. 2 times 3 is 6. Okay. Now that I've done that, I can say this. If 3 plus negative 5 equals this over here, 2 plus a negative 4, comma, then this 3 plus negative 5 times negative 3 equals this 2 plus negative 4 times negative 3. Let me fix that. I was off my board here. Times negative 3. Okay? There's my if-then statement. So in other words, if this equals this, then this times negative 3 equals this times negative 3. Okay, that is the end of lesson 21. Review the lesson summary and go do your problem set.